Okay, the purpose of this video is to review with you and kind of refresh your memory on some basics of how to do an electron configuration. So you remember in some of our lessons we talked about how there's more to an atom than just basic energy shells, big rings, so to speak, okay? There's these main energy shells, but within them are what we call subshells or sublevels. And electrons don't necessarily exist just in a main energy ring. They exist in these separate sublevels, all with a slightly different amount of energy. Now, in an electron configuration, we use numbers, these big numbers, 1, 2, 3, 4. Those represent the principal or the main energy shell we're talking about, the main energy level. The letters, S, P, D, and F, represent a different type of sublevel that has a little bit more or less energy than one around it. And the letters really mean you have different shapes to those sublevels, and that's kind of beyond the scope of this video here. The basics we need to recall. An S sublevel can hold up to 2 electrons. It's very small in capacity. A P sublevel can hold 6, D can hold up to 10, and F can hold up to 14. Those are the maximum capacities. Doesn't mean they'll always fill up, but that's what it can hold. Now you see these green arrows. We're going to follow these arrows because energy shells don't fill up with electrons the way you would necessarily think. It's not like 1, then 2, then 3, then 4. A lot of these sublevels, for lack of a better way of explaining this abstract stuff, they overlap with each other. And so in this case, for example, 3D fills up after 4S. So it's like the third energy shell and the fourth energy shell kind of get squished together and overlap. And so it doesn't necessarily go in the order that you think. So what we're going to do is follow these arrows. The 1S fills up first, then the 2S, then the 2P, then the 3S, and so on. And we just keep working our way down. 7P is the largest one we're ever going to have to consider. Now, using this, figuring out the maximum capacities, and then getting this to relate to a specific atom is really not that difficult as long as you understand what the numbers represent and letters. So let's take a look at phosphorus. First thing we would do is find it on the periodic table. We'd identify the atomic number, which is the smaller one. Okay? It's a whole number, 15. That means phosphorus has 15 electrons. Now all we have to do is fill up these subshells, the sublevels, until we run out of our 15 electrons. Excuse me. So the first thing I'm going to do is say, all right, the very first set of electrons is going to fill up the 1s sublevel. So I say we have a 1s, okay, that means the first energy level, the s sublevel, and it can hold up to 2 electrons. So I put a little 2 as an exponent, that means there's 2 electrons that would exist in that first sublevel. After 1s is filled up, the next electrons are going to fill up the 2s. We go back to the beginning of this arrow and we follow it through. And 2s, even though it says a 2 in front, that's just the s sublevel in the second ring or the second shell. That can hold also just 2 electrons. It's an s, that's all it can hold. So the next 2 electrons go there. Okay. After 2s gets filled up, the next thing is 2p. Now the p sublevel is different. It can hold up to 6 electrons, so I put a little 6 up here. And now I kind of stop for a second and take a sort of a calculation of where I'm at. 2 electrons went here, 2 more went there, that's 4. 6 more went there, that's a total of 10. So right now I've placed 10 electrons, the first 10 electrons in phosphorus. But phosphorus has 15, so I got 5 more to go. So I just keep going until I run out. Okay, after 2p fills up, then 3s is going to fill up. And an s can hold 2. Okay, so now I've got 2, 4, plus 6 is 10, plus 2 is 12. Okay, after 3s comes 3p. Now, a p can hold up to 6. Okay, but we don't have 6 left. If I do my math up here, we place 12 electrons. There's only 3 more until we have our 15 electrons that exist in a phosphorus atom. So those final 3 will go in the p sublevel. So this one is unfilled. And based on what happens in this outside sublevel, that kind of tells us what other things it's going to interact with and how it interacts with them, just based on the fact that it's got room for more electrons or it could give some away. We'll get to that down the road with bonding. This is the complete electron configuration for phosphorus. Now let's take a look at copper. I want to compare these. Okay, copper, here's the mass. We don't care about that. That's the number of electrons. That's the atomic number. I got 29 of them. Okay, let's start the exact same way. It's going to look just like phosphorus, but it's going to end differently. So 1s holds 2, 2s holds 2, 2p holds 6, 3s holds 2. Notice this looks just like phosphorus. It's the way it ends that's going to make it different than the rest. I've placed 12 electrons so far. 2, 4, 6 plus 6 is 12. I got to go all the way to 29 now. So after 3s, I go back to this arrow. 3p is going to get filled up. And I know p can hold up to 6, so I put the 6 electrons there. After 3p comes 4s, and an s can hold 2. Okay. Now look at where we're at. 2, 4, 6, 8, plus 6, plus 6, that's 8 plus 12, which is 20. Okay, I placed 20 electrons, I got 9 more to go. Okay, where are those 9 going to go? Look what comes after 4s, 3d. Here's the first part where we find it's kind of a weird order. 3d you would think go here, but this is where the third shell and the fourth shell kind of overlap and get squished together, and it doesn't fill up the way you would think. A d can hold up to 10. Do I have 10 electrons left to place? No, there was 20 of them here. I got 9 more to go. So I'll put the final 9 right here. Okay, so that 3d did not fill up all the way, but that's the complete electron configuration for copper. Okay, now I'm going to show you how to abbreviate these. We've learned in our lessons that we're going to use noble gases to abbreviate. So what I need to do is I need to look at atomic number 15. This is phosphorus. I want to go backwards in number and find the first noble gas that I come to that has its S and P sublevels completely filled up. And if I look on the periodic table, I'll notice that neon is that first one. It's number 10. So the first 10 electrons here, we're saying look just like the configuration of neon. So this looks just like neon, electrically speaking, except for these extra 5 electrons on the end. Okay, so I could write neon in brackets and do 3s2, 3p3. And that's the abbreviated version of that electron configuration. Let's take a look down here at copper. If we go to number 29, which is copper, let's go backwards in number on the periodic table until we get to a noble gas. Okay, and the noble gas that comes before this one is argon. Okay, argon is number 18. So argon is the same as the first 18 electrons. That's this right here. It's the last S and P sublevels that are filled up. So instead of writing those first 18 electrons, we can just write argon in brackets. So it looks just like argon, but then it's got extra electrons in the 4s and the 3d sublevel. That's the abbreviated version. These are the complete unabbreviated versions, and they're all the same. It's okay, you can use either one, because what really matters is what does it end like? What does it look like at the very end? Okay, is there a way to get the abbreviated version without having to do the long version first? Yes, there is. We're going to work on that in our lessons, and you're going to have to take a look and see if you can catch on to the shortcut from the periodic table.